automation will be there in suffix trees. A suffix tree is nothing but a suffix compressed trie which has suffix automata. We built the whole classic automata, right, with the failure functions. You have to build the same way, but you have to compress the nodes like this. So that is suffix tree. You can do the same operations you did with suffix trie using suffix tree, but building it in linear time is difficult. It's called as Euclidean algorithm. You can Google it if you want. This will make you the suffix compressed tree. Suffix compressed tree. In O of n, or there are relatively easier ways in n log n. But we are going to learn about suffix arrays, which can do almost similar functions as a suffix tree. So a suffix array. So the problem with this is storing the suffixes itself. Do you want to store suffixes itself or just a suffix number? So I'll come to that. So suffix array is given a string is order all the suffixes in sorted order. So same way. A, B, C, D. So the suffixes are A, B, C, D, B, A, B, C, D, A, B, C, D, B, C, C. So if I sort all the suffixes, what will be the order? So this was suffix at index 0. So this was suffix as index. That is called SIS, suffix index. So suffix at index 0 is this 1, 2, 3, 4, 5. So what will be the sorted order? Sorted order will be A 0 will be first, second will be 2, third will be BA1, then 3, 4, 5. This is the sorted order of suffixes. So how do you build the suffix then? The brute force method will be to find all the suffixes, store them in a vector of string, sort them lexicographically. What will be the complexity of that?
N
so there are
space and time n square.
N square time.
Space also.
What will be the time?
N square.
N square log n.
N square log n.
N square log n. N square is the total size, and n square because of the sorting will have n square log n. So this is the brute force. And this will actually time out if you want to solve it for problems, because they will give things like 10 power 5. So what is the better way to do it? Let's see that. It's actually a very beautiful way. So the thing is, if I store this, can I sort two strings based on the first 2 power k values, 2 power k characters? So I want to solve this problem. Given two strings S and T, I want to compare them only based on the first 2 power k characters. So what I'm doing is, I'll first check the first character. If they are not equal, then that means that I can know the order from there itself. But assume the first character is equal, like A, B, C and A, C, D. So first I'll compare the first character alone. So they are same. So I can't say anything about that. So I have to go to k equals 2. So k equals 2 will compare A and A. They are again same. So I have to go to k equals 4. So this 4, here if I compare the string length of 4, I can find out that A, B, C is smaller than A, C, D. So I know that the position of this is, let's call it PA, Pj. So position of I is less than position of J. So let us consider for an arbitrary k. Let's call that, so PA of k, and so this notation means I am comparing a string or a suffix at index I and suffix at index j after by just the first 2 power k characters. So assume I know PIK and PJK for 2 strings. So if they are not equal, I can get the relationship from that itself. So if they are equal, I have to go to k plus 1, right? So I have to check these 2 values, PA of k plus 1 and PJ of k plus 1. So if you see, this P of the k plus 1 will have 2 power k plus 1 characters, right? This is nothing but 2 into 2 power k characters. So I can split this new string as 2 equal size offline strings. Same way, like here, this full length 4, AA, BC, was nothing but AA and then BC. Same. So here, so what you can do is, assume you know at every position, you know for its 2 power k position, like okay. What I mean is for k from, so what will be the maximum value of k? There can be just log n. So let us call this step. So step can be from log n till 1 or 0. So for every index I store what is the position in the same way, like pi k for every k belonging to step. So once I know this position, I can easily compute for k plus 1. So for an example, so just for BC, right? Okay, we should have a single string. Like this is generalized for any 2 strings, but in suffix arrays, we are just sorting the suffixes of the same string. Just write it here. So for every so this AA is part of the suffix, the full word. This AB is part of the suffix, BC is part of the suffix, CD is part of the suffix. So first I'm just comparing.
The last one CD would be.
So initially I'm building it for this is k equals 1, right? There's the 2 length string. So assume I build this table. So what is the position of these? With the initial, this is the suffix order, the order of the suffixes, so it will be 0 normal. So what will be it will be the same order. It will be 0, 1, 2, 3. So now when I go for k equals 2, what should I compare? So for AA, so for the first thing, it will be this whole thing of 4 characters. That I can split it as these 2. I already know the position of this. I already know the position of this. So let me just make it as a tuple. So for the suffix index 0, 1, 2, 3. So the tuple will have the current position of the first value and the second value. What is the position of the first value? Position of second value 2. Sort of. So for